Welcome back, everyone. In this video we will be covering distance scales of astronomy. So the first term that we will learn about is called the astronomical unit, also known as the AU. And basically the AU is the average distance between Earth and the Sun. And this is about 150 million kilometers. We can express this as 1.5 times 10 to the 8th kilometers. I suggest that you remember this value as it is commonly used in many equations, and sometimes you may have to address this in the future. The second one we're going to address is called the light travel time, and this is basically the speed of light. What is the speed of light? It's how fast light travels in a vacuum, and this is defined as c, and it's approximately 300,000 kilometers per second. It's also considered as a constant because it's the largest possible speed. So given these two terms, we can make an equation. Let's try to figure out the time that it takes for light to go from the Sun to Earth. So take a moment and try this on your own. We can address this problem by using an equation. This is also known as distance equals velocity times time, d equals vt. We know that velocity equals the distance over time, and acceleration equals to the velocity over time through simple calculus. And so since we can use algebra to make it to vt equals to d, we can solve for t by dividing v. So d over v equals t. And we know that the distance, the average distance between the Earth and the Sun is 1.5 times 10 to the 8th kilometers, and that v is 300,000 kilometers per second. And since we know this, we can cancel kilometers out and figure out the time it takes to go one way. Also know that 1 light year is equivalent to 10 times 10 to the 12th kilometers. So we have 1 year. That's what we're trying to find. So we can start by knowing that 60 seconds is equivalent to 1 minute. And we can multiply that to 60 minutes over 1 hour to cancel the minutes. And to cancel the hours, we need to know that 24 hours are in 1 day. And now we need to cancel days by knowing that there's approximately 365.25 days in 1 year. So that we can cancel all of these units and be left with seconds. After we multiply all these values out, we can get that there's approximately 3.156 times 10 to the 7th, and because we know that to the 7th, it's a really large value, seconds. Now before I end the video, I want to address an important concept, and this is relevant to the time or distance scales that we addressed earlier. The nearest star that is closest to us, besides the Sun, is called Proxima Centauri. And as you know, we measure distance in terms of light years because it's really far away, and that this would be 4.2 light years away. So always know that this is the nearest star closest to us besides the Sun. Other stars, we can see them at a larger distance, so we actually see them farther back in the past. Our nearest galaxy closest to the Milky Way is called the Andromeda Galaxy, and this is about 2.4 million light years away. Other galaxies and stars are actually much farther away from us. So how would we measure this? But luckily, we have something called the speed of light, as I mentioned, was 3.0 times 10 to the 5th kilometers per second. And because of the finite speed of light, we are able to detect and measure other galaxies farther back in the past with this fossil record of the universe's history. It gives us a time scale and a measurement of things that are farther back. Thank you for watching.